All right. Hello, all. I'm going to do just a brief portion of the lecture here. If you are in the 12:30, 11:13 class, we did not get to this example in class. If you were in the 2 o'clock class, we got to this one, but very briefly. And I know this is a confusing topic, so I wanted to include this example. That way, if you already saw it in class, you can have the opportunity to look through it again. And if you did not see it in class, I want you to have an example of this to help you with your homework. So this is an example of phase shifted sine and cosine graphs. So just to kind of refresh our memory here, our graphs of sine and cosine, I'm just going to fill them in really quickly here. Okay, so our basic sine graph, our normal period is 2 pi, and we're going to cut that into 4 equal pieces. So you start by cutting it in half and then cutting it in half again. And the sine of x has an amplitude of 1, so we're going to go up 1 and down 1 from our baseline. Sine starts at the origin, bounces up to the top, back to baseline, down to the bottom, and back to baseline. So here is, oops, have to come all the way back down. Here's our basic sine graph. Sorry that that's so rough, but that's the basic shape. And our basic cosine graph, again, our normal period is 2 pi, so we'll cut that in half and then cut it in half again. And we have an amplitude of 1, so we're going to go up 1 and down 1 from baseline. The basic shape of a cosine graph starts up, comes back to baseline, drops down to the bottom, comes back to baseline, and then goes up to the top. So it looks like this. Basic shape of a cosine graph. Okay, and we're going to be dealing with transformed functions here. So change this to a minus and this one to a minus. When we're finding transformed functions for sine and cosine, I want you to identify A, B, C, and D. And then first thing I want you to find is the period. The period of our transformed function is 2 pi divided by B. Our amplitude is the absolute value of A, so it's the magnitude of A. However big the number is, if it's negative, don't take the negative with it. It's just the positive value of A is our amplitude. And the next thing we have to find is our phase shift. Now, phase shift, again, is the horizontal sliding left and right, and that comes from C divided by B. And again, this negative is built into the format of our equation. And so we'll have to keep that in mind when we're finding our C value. Okay, so let's do an example of this with a phase shift. So we ran through a couple of these examples in class, but I really want to do one with a phase shift so that you can work through finding your X values with a phase shift, because this is one of the more challenging topics in this section. So I'm going to identify, again, our form is y equals a times the sine of bx minus c plus d out here on the end. So we're going to start by identifying A, B, C, and D, and then we'll find our period, our amplitude, and our phase shift. So in here, my A value is 2. My B value is also 2. My C value, this negative is built in right here. So my C value is just 2 pi over 3. I promise that building the negative into our formatting of our equation is really going to help your brain out. And then D, I don't have a d value here, so that's just 0. So what that means is the period of this transformed function is 2 pi divided by b, which is 2. 2 pi divided by 2 means our period is pi. So we're going to complete our entire sine wave in a length of pi instead of 2 pi. And our amplitude is the absolute value of a, which is 2, and the absolute value of 2 is 2. So our amplitude is 2. We are going to bounce up 2 and down 2 from the baseline as we wave. And then our phase shift here is going to be c divided by b. Our c value is 2 pi over 3 divided by our b value of 2. Again, fractions inside fractions, we're going to keep change flip. So we'll keep the top, change the division to multiplication, and we're going to multiply by the reciprocal of the denominator. This one's kind of weird. 2, I'm going to write that as 2 over 1, so that when I multiply by the reciprocal of the denominator, I make sure I get it right. So now I'm going to multiply across. I have a little bit of canceling to do. And overall, my phase shift is pi over 3. So what that means is that instead of starting my wave at x equals 0 like normal, I'm going to start my wave at x equals pi over 3. Okay, so let's see if we can figure out how this is going to work. So when we create our graph, our period is going to start here at pi over 3. This is where my sine wave will start. And it's going to take me a period of pi to complete my wave. So if I start at pi over 3 and I wave for pi, like a length of pi, the x value where I end is going to be pi over 3 plus pi. That's going to be this x value right here where I'm done waving. So to figure out what x value that is, I have to add these together. So I need a common denominator. That common denominator is 3. I already have one here. Pi becomes 3 pi over 3 with my common denominator. So this x value here is 4 pi over 3. Okay, so I start my wave at pi over 3, and I'm going to end my wave at 4 pi over 3. Now to fill in my sine graph, I need to divide this region into 4 equal pieces. I need to find a halfway point, a quarter point, and a 3/4 point. So first I'm gonna divide this in half, and then I'm gonna divide it in half again. Usually we can kind of logic out our x values, but when you have a phase shift, it is incredibly difficult to logic out these halfway points. So instead, what I want to think about is if I have a whole period of pi, that's the length that it takes me to do my entire wave. If I cut that period of pi into 4 equal pieces, each of these pieces will have a length of a quarter of that. So that means pi divided by 4. So the length of each piece here is pi over 4. I'm going to divide my period by 4. So the length of each is pi over 4. So now to find these x values, I'm going to find my, let's find our quarter point first, and then we'll find our halfway point, and then we'll find our 3/4 point. So to find this quarter point right here, I'm going to start at pi over 3, and I move over a length of pi over 4. So to find that x value, I'm going to take pi over 3, and I'm going to add to that pi over 4. In order to figure out what that x value is, I need to do a little bit of addition. I need to get a common denominator in order to add these. To go from pi over 3 to a common denominator of 12, I have to multiply by 4 over 4. So that becomes 4 pi over 12. And then pi over 4, I also need to create another fraction with a common denominator. To get a common denominator of 12, I need to multiply top and bottom here by 3. So that becomes 3 pi over 12. Now that I have a common denominator, I can add those together and get 7 pi over 12. That is the x value at this quarter point right here. That's 7 pi over 12. Okay, great. Now, to get my halfway point right here, you can either start at the 7 pi over 12 and add another pi over 4, or you can kind of start at the beginning and add 2 pi over 4s to get to my ending point. I like to do that, but it's really kind of up to you, because it makes more sense in my brain as I'm working here. To get my halfway point, I'm going to start at pi over 3, and I'm going to add 2 pi over 4s to get there. And similarly with that thinking, to get my 3/4 point here, I'm going to start at pi over 3, and I'm going to add 3 pi over 4s. So that's how you find your half and your 3/4 point. Again, to add these together, you need a common denominator. So I'm just going to kind of go through these really quickly. Hopefully this will make sense. Just get a common denominator here. So I'm going to just get my common denominators, add these together. That's 10 pi over 12, which reduces to 5 pi over 6. So that's my halfway point right here. And again, I'm just going to kind of go through and add these together really quickly, because this is arithmetic that you might have to slow down and think about. Take your time with this. I just don't want to take a whole lot of time on this because I know your time is valuable. So I'm just going to try to get that in. The big thing here is how to kind of logic out these values. So your quarter point is going to be wherever you start plus 1/4 of your period. Your halfway point is going to be where you start plus 2/4 of your period. And your 3/4 point is going to be where you start plus 3/4 of your period. And then you can kind of fight through the arithmetic to get these x values. Now, once you have your x values, the hard part here is done. So here's where we're going to start our wave at pi over 3. We're going to end our wave at 4 pi over 3. Our amplitude is 2, so we're going to bounce up 2 from our baseline, and we're going to bounce down 2 from our baseline. Our base function here is sine, and we don't have to flip it upside down. So that means that the overall shape of our sine is going to stay normal. And if I come back up here, reminding you what the basic shape of sine is, it starts at the baseline, bounces to the top, comes back to the baseline, bounces to the bottom, comes back to the baseline. So that's how we're going to fill in our y values down here, all the way down here. So to fill these in, at the start, I'm going to be at the baseline. I'm going to bounce up to the top. I'm going to come back to the baseline. I'm going to bounce down to the bottom, and I'm going to come back to the baseline. Those are how you get your points. And then when you're putting this into ALEKS, once you have these 5 points, you'll plot those points in ALEKS, and then you'll hit the button that says fill in my graph, and it will put in a nice smooth wave for you. It'll be prettier than mine, but it'll fill in the shape of the graph. It'll look something like that. And we have graphed a sine function with a phase shift. That's a, this is one of the more complicated versions of these graphs. So I wanted to make sure that you had an example of that. And even though we covered this a bit in class, in the 2 o'clock class, I wanted you to have the opportunity to go through it again in case it was confusing the first time around. So thanks for watching this. Make sure that you go back and also watch the rest of the lecture. This was just kind of a bonus video that I wanted you to have. And then we'll start the rest of the lecture in the other video. So thank you for your time, and I'll see you in the next video.